All right, everyone. Hello and welcome to the Edge of the Earth podcast. I think we've got a great show for you today. Today we're going to be covering basically the universe and space and everything in between. We're going to walk through the solar system and find out what all is in our local, little cluster of planets. First off, I want to start today's episode by thanking everyone for listening, and I want to thank all of my followers so far. I'm up to 57 on Spreaker, and I need 100 total, so we're getting there, making a lot of good progress. I want to thank specifically a lot of the early followers, some of the ones that I work with, like Christina, Renee, Bethany. Also want to thank Chris from Facebook, a good friend, Glenn, my father-in-law, Christy, my lovely wife, her friend Marissa, well, mutual friend, I guess. And I actually follow it myself with my other Twitter account. Billy from work, my mother Rebecca, good friend John, and also Frank from work. I really appreciate all that. And also Skylar, another friend from Facebook, and he's been on the show actually. I think I've mentioned him 3 episodes in a row now, so there you go, Skylar, you're getting some shout-outs. All right, so also, if you want to check out the website, it is jeffjarman.tk. Also, you can check out the Twitter account and the new Spreaker account. Twitter is at EOTE podcast, at Edge of the Earth podcast, and also on Spreaker here I'll be posting links. And when this episode goes up, obviously you'll know how to get to the site. Also, we're on iTunes right now. Just search Edge of the Earth in iTunes and follow us on there or subscribe on there, and all the episodes will automatically be downloaded to your iPhone or your device, whatever you happen to be using. So that's pretty cool. We're working on getting on iHeartRadio, but that, again, is after we get 100 followers on Spreaker, and I have unlimited podcast space on this website. So, have you ever been driving or just been outside walking or something, and you just happen to look up at the sky, and you just think about the fact that you're staring off into space? It's really crazy. I mean, if you just take a moment out of your daily life and look up and think that you're staring off into the distance, looking at other planets, stars, other galaxies. I mean, obviously you can't see all of them with your naked eye, but that's what you're looking at still, either way. And we're not actually that far from space. I mean, if you took your car and got in your car and you could drive straight upward, you would be in space within an hour. It's that close. And it's really just mind-blowing. And one interesting fact is that everything that we've seen so far, everything with all of our telescopes and satellites and everything, only makes up 4% of the universe. We've only seen 4% out of everything that we know. This is, again, just kind of a random little fact here. Our farthest spacecraft right now that we have is Voyager 1. And that's the one that has the golden record on it, or whatever it is, and it has, like, the sounds of the Earth, and it has music on there, and basically a message for aliens, essentially, if they ever picked up this thing. And this satellite actually just entered interstellar space, which is really far away. It's beyond Pluto and all that stuff. Right now, it would be going through the Oort cloud, which is basically the leftovers from the formation of our solar system. It's 1 trillion frozen comets left over. So just think about that. I mean, it would be hard to get through that unscathed, I would imagine. But then again, they're pretty far apart. I mean, a lot of the bodies in this area are actually as far apart away from each other as the Earth is from Saturn, is about the relative distance. And you'll understand just how big that is today by the time I get done with this. I've got so many notes. I'm going to try and get to all of them, and the Big Bang Theory. So it is a theory, but there's a lot of really good evidence to go along with it. The Big Bang, the whole universe started with something that was smaller than the size of an atom. Some of the evidence of this is the amount of helium that we find in the cosmos, and also the glow of the radio waves that we see afterward. And everything is slowly spreading apart in space. Everything is slowly drifting away from itself, and it's all drifting away from one point. So that is part of the evidence that we have. Obviously, it happened a long, long time ago. So after the Big Bang, there was a long period where everything had to cool down, and it was completely dark for about 200 million years. And eventually, gravity started to pull together the clumps of gas and started to heat them, and that's what formed stars. So that's how we have the sun and all these other things. And those are what made the first small galaxies. Our galaxy, which is the Milky Way galaxy, formed about 11 billion years ago, and our sun in particular was born about 4.5 billion years ago. And in space, just to give you an idea, there are actually hundreds of billions of stars. hundreds of billions of stars. And also, just kind of a random fact, you've always heard people say there's no sound in space, and like in the horror movies, they can't hear you scream in space. Sound waves need a medium to travel through, and since there's no atmosphere in space, there's nothing for the sound to go through or transmit by. So that's why you can't hear anything in space. So then, now that we've gone over how everything kind of started, let's talk about the Earth in particular for a moment. We all know a lot about the Earth, so I'm not going to cover that really in depth, but one little fun fact is that our moon actually used to be 10 times closer to the Earth. Think about what that would look like in the sky. I mean, that would be insane. And what pushed it away over time was the tidal friction. We used to have tides that were way bigger than we have right now. And over time, all of that kind of pushed the moon away to where it is now. Whether it's still being pushed away or not, I'm not sure. And then, so we have the dinosaurs, and they existed for a lot longer than I had previously thought. I mean, it's kind of, I never really put a whole lot of research into it, but the dinosaurs actually existed for about 100 million years on Earth. So these dinosaurs were actually roaming the Earth for 100 million years. It's kind of interesting that they never evolved past what they were. The smaller mammals that were, kind of under toe of the dinosaurs are what we eventually evolved from, in theory. And if you want to talk about other life in space and things like that, there's actually 40 billion Earth-sized planets in the habitable zones around their stars in the Milky Way galaxy. This is just in the Milky Way galaxy, 40 billion Earth-sized planets in the habitable zones, which is just close enough and just not too far away from their suns, basically. The sweet spot, if you will. So then now, let's go over our cosmic address. A lot of people don't know what space is exactly. Like, they hear all these terms and all these words, but they don't exactly know what space is. So, let's start from Earth. That's where we are. And Earth is inside the solar system, which is our set of planets. It's the Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto, if you want to count that as a planet anymore. And so our solar system is inside the Milky Way galaxy. And there are many solar systems inside the Milky Way galaxy, as I said earlier, the 40 billion Earth-sized planets alone that could have life. If you want to think about galaxies, then there's another galaxy, our closest one is the Andromeda galaxy. And all these galaxies together are considered the local group. And outside of the local group, even further out, you have the Virgo supercluster. So imagine like the local group here, and there's another group over there, and another one over there, and they all make up the Virgo supercluster. And outside of that is just what they call the observable universe. And there's at least 100 billion galaxies. 100 billion galaxies. Yeah. So, now you kind of got an idea. I mean, that makes us feel pretty small, right? So, I mean, and this is 4% of the universe. So, we're about halfway through the podcast, and now we're going to start going over our solar system in particular. The planets have always been really fascinating to me, and I always felt like I didn't know enough about our solar system because this is our home, basically. This is our home. These are our neighboring planets. So it's nice to know things about them and things, because we can see these things with our own telescopes. We don't have to be, controlling a satellite in deep space to see these things. Well, some of them, up close, obviously, but still. So let's start with our sun. Our sun actually dwarfs Jupiter. It's huge. It would actually take 1 million Earths to fit inside the sun. 1 million Earths to fit inside the sun. That gives you an idea of how big it is. It's 1 million times the size of this planet. The sun is actually white. It burns white hot. The only reason that it looks kind of yellowish or orange to us is because we're seeing it through the atmosphere. It's the same effect as the moon almost. Like when the moon is straight up above you, sometimes it'll look smaller as opposed to when it's on the horizon, something like that, or like in California on the horizon with the water and everything playing effects on it. It's almost like a fishbowl effect. Like it magnifies the way that it looks through the atmosphere. So that's why sometimes it'll look bigger and smaller, not counting when we have like a supermoon or whatever, when it's really close to the Earth. But as I said, the sun naturally, if you were looking at it in space, is white. And light from the sun actually takes 8 minutes to reach Earth. So like say that you shut off the sun, no light coming out at all, we would still see the sun for the next 8 minutes. We would still see that light coming at us for another 8 minutes. That's why if, something big happens way out in space and it's like 5 light years away, this star blows up or it dies, it would take those 5 light years, it would take 5 years for that light to reach us, and we would still see that star like it was still there and still perfectly alive for the next 5 years. So now let's focus on the planets. Let's go to Mercury first. Mercury is the smallest terrestrial planet, and the way that it spins, its year is only 88 Earth days, so it goes around really quick. The surface of Mercury is actually similar to the Moon. It has plenty of craters on it and things like that. Temperatures there actually reach up to 800 degrees Fahrenheit during the day, and on the night side of the planet, 300 degrees below zero. So it's definitely not a very hospitable place. Speaking of inhospitable, let's move on to Venus. Venus is the brightest object in the sky at night when we're looking from Earth, even brighter than Jupiter. Now this planet has had troubles with a runaway greenhouse effect. It traps heat in the atmosphere, and it's creating a desert basically on the surface. It's definitely the hottest planet in the solar system. Temperature is reaching 870 degrees Fahrenheit on the surface. It rotates so slowly that one day is 4 Earth months. That's how slowly the planet turns. Basically, the surface is full of rolling volcanic plains. As I said earlier, we all know Earth pretty well, so we're just going to skip over that one for right now. Let's go on to Mars. Mars is home to the tallest volcano in the solar system, which is Mount Olympus Mons. It has a valley that actually dwarfs the Grand Canyon. It's known as the Red Planet. It has seasons and polar caps. It actually has seasons kind of like here on Earth. It has dust storms that can actually cloak the entire planet. You've all seen most of you have probably seen The Martian by now, so you've seen this dust storm type effect on camera at least, or what we think it would be like. And due to the latest discovery, we think that there is water on the surface, or there has been within even the last few months, actually. Now, outside of that is the asteroid belt, basically remnants of planets that never actually formed. These asteroids never got the chance to cling together and form a planet. That leads us to Jupiter, which is the largest planet in our solar system. It spins so fast that one day there is 10 hours long. This huge planet spins all the way around in 10 hours. So obviously there's going to be constant high wind speeds. It's surrounded by faint rings and has over 63 moons. The storms on this planet alone are bigger than the Earth. Its moon Europa has an icy surface with probably water below. Everyone's heard of Europa. The moon Ganymede, I hope I'm saying that right, is actually the largest moon in our solar system. So then let's go on to Saturn next, which has the rings, the famous rings that everyone knows about. It's made up of snowballs, basically, rings of ice, rocks, and dust, held in place by its 60 moons. It's the least dense planet. It would actually float on water if it was able to be on a body of water that big, obviously. So next up is Uranus. It gets about 400 times less sunlight than the Earth. It's the first of the ice giants. And this planet is actually strange because it actually lies on its side. It has an extreme tilt, and it causes the seasons that can last 28 Earth years. Can you imagine it being winter for 28 years, or summer for 28 years? That's what happens when the planet is so far on its side that it's almost sideways. It also has faint rings that go around the planet. Then moving on to Neptune, this planet is colder than Uranus, with seasons that are less extreme. It radiates more heat than it actually gets from the sun. Triton, one of its moons, the theory is that it actually captured Triton when the moon passed too close to the planet and got caught in its gravitational pull. And then outside of that is the Kuiper Belt, the Kuiper Belt, the Kuiper Belt. This is made up of comets, rocky bodies. Pluto is in here, as well as any other possible planets that we might find one day. And with that is our tour of the solar system. Hopefully you've learned a few things from this little tour. And I know it was kind of short since we're in a time limit here, but at least I think you have a better idea now of what is actually in our solar system. And you can always look up pictures and things like that of these planets. And hopefully pretty soon we'll have better images and we'll be able to see these planets a little bit more closely in the future. So, and guys, please remember to follow this podcast on Spreaker. It's completely free. It helps us out so much, and it's going to be the one thing that allows me to keep doing this going into the future. And if you enjoy this, please share it with your friends, and help everybody to find it and, get to listen to it and all that kind of stuff. So I really want to keep doing this going into the future. And so if you guys can do that and follow it, it's not going to spam you. It's not going to cost you anything, like I said. So it's completely free, and it would just help me out a ton. So, and remember, we launch our episodes every Saturday morning at 6 a.m. so you can catch it on your drive to work in the morning or wherever you happen to listen to it or whatever time you happen to listen to it. But it does launch Saturday mornings. Again, thank you all for listening. Thank you for the support. I really appreciate it, and I will see you right here next week at the Edge of the Earth.